So in this presentation, we're going to talk about why I have a problem with the search box and why you should too. And we're also going to have a look at some solutions to the issues that it has and demo some software based on these ideas of how to solve this problem. So I think we've all had the experience of doing the wrong thing with the door and then walking away and feeling a little silly about ourselves. And the good news is it's not always your fault. In fact, most often it isn't your fault. And I learnt this from a very interesting book that I read some time ago called The Design of Everyday Things by Donald Norman. And he pointed out something that I hadn't quite realised was obvious, which is that bad design is everywhere. So when somebody puts a handle on a door that you're supposed to push, then of course you're inclined to pull it rather than push it. And it's the designers that are at fault. The solution can be just to simplify it. If they'd have just taken away the handle, then clearly there's only one thing you could do with that door, which is to push it, and nobody would do the wrong thing. So simplification can often be very useful, but oversimplification is equally bad, I think. So if you were to design a door like this, which is a pull door, but you forgot to put a handle on it, then obviously that would clearly be an oversimplification. The tool is not sufficiently complicated for the job that it's designed for in this case. And that's the subject of one of Donald Norman's other books, which was called Living with Complexity. And in this book, he talks about that certain tasks are inherently complex, which isn't a dirty word, it's just the job is a difficult one. So flying a 747 passenger jet is an example of something which involves a lot of tasks and a lot of things that need to be monitored. And that's why when you look at a flight deck, it's quite a complex looking device for that particular job. Which brings us to the search box. So it's an everyday thing that we encounter pretty much on a daily basis. But in my view, it's lacking features that just don't make it good enough for the job that you're trying to do, especially if you're doing sort of a Boolean search, which is something that we'll come to shortly. Don't be too scared by that term if you're not familiar with it. The search box has limited functionality. There are no sliders, there are no checkboxes, there are no buttons. It's just a white box that you type text into. The functionality that it does provide, the features that are hidden away in there, often require sort of cryptic commands, which are confusing even for experts. The commands can be ambiguous. It's quite possible and quite easy to write something which could be taken two ways. And it's quite error-prone. So some of the errors are ones that are noisy and blow up in your face and say you're missing a bracket or something like that. And some are silent errors where you would never even know that it was doing the wrong thing. So let's have a look at an example of searching. So you type in two words into the search box and hit enter, and behind the search box this is constructed into a flow. And every database and every search engine pretty much uses this idea of Boolean logic, which I mentioned earlier. And that's essentially something that looks like this. So behind the scenes it constructs a sort of a pipeline where documents go in one end and it gets fed through a series of filters, and the documents that match the filters, fish or tank in this case, they will drop out as matches in the final results. So for our particular query here, we have a document that matches both fish and tank, so that appears at the top of the results because it matched both of the things we were looking for. And then we have a series of other documents which match perhaps only one of the choices that we had, like fish or tank. And the net result is we can potentially have many millions of documents matching our query. The best ones are at the top, hopefully, and the lesser quality matches are somewhere off into pages 2, 3, 4, 5, 6, 7, and so on in the search results. It can be quite hard to sort of deal with millions of matches, which is why we often see in a search engine these sort of filters that summarize all of the search results. So you might have millions of search results, but you can sort of narrow down by, in this case, materials. So we could pick all the glass fish tanks or the acrylic ones, but then we might be surprised to see that some of these fish tanks are made out of armoured steel. And that can be a bit surprising because we didn't realise that actually what the search engine was doing was looking for fish or tank, and preferably both. So we do actually match some armoured tanks down here. Quite a strange shot, I must admit, to have a combination of fish tanks and armoured vehicles, but here we go. Just for the point of illustration, that's what we're going with here. Also, things like prices, we will see that there's stuff in the $10 to $20 range, $20 to $50, and then 75 million plus. So this is perhaps an example of where we should be careful about what statistics we take and use from these kinds of search engines and databases. So when you have a very sloppy query, which is looking for fish or tank, then if you were to take away the average price of a fish tank from this, then you might be surprised at 75 million being a very high figure. So it's not always clear exactly what you're matching when you use this OR type of pipeline. And that's why search engines often have a big switch, which allows you to switch away from using OR to using AND as the sort of Boolean controller. So ANDs are quite different to ORs. It's basically matching all the words rather than any of them. So it arranges a pipeline that looks like this. We're looking for documents that match both fish and tank. So you only make it through this pipeline if you can get through stage 1 and stage 2. And we only match fish tanks, which is great. And that's why most search engines actually run with a AND. The problem with that is that people don't realise that the more words they type, the less results they see. So if you were to type fish or reptile tank, so you're looking for fish or reptile tank ideally, then we would construct a pipeline that looked like this. Fish and reptile and tank must be in all matching documents. And the problem becomes is that we have documents that match fish, but we don't have documents that have both fish and reptile in them, which is unfortunate because we never get to find out that that's the problem. So fish is spelt correctly and it's in the index, reptile is spelt correctly, it's in the index, and tank is spelt correctly and it's in the index, but we don't have a single document that contains all three of those words. So we never really get to find out, we just get told there's no results at all, which is a bit of a shame. So that's why one of the things I think would be useful is if the search engines were more transparent and they actually showed you what we're seeing here, which is you've got a blockage in this pipe because of the way it's arranged. So this choice between ANDs and ORs, ORs often match too much. So we had tanks and just fish rather than fish tanks. And when we have ANDs, we often match too little, so the more words we type, the less likely we are to match anything at all. And that's why search engines offer inline controls. So you can put ANDs and ORs in between selected words in your text box. So let's have a look at an example of how that would work. So if we type fish or reptile tank, then what happens is we match reptile tank, but we also match fish, which is a bit surprising because the way that's been interpreted is it's looking for things which are fish or things which are matching reptile and tank. And it's ambiguous. So we meant one thing and the search engine meant it entirely different way. And to remove that ambiguity, we have to add brackets. So we have to tell the search engine we're looking for fish or reptile, followed by tank, and that's will give you the pipeline that looks like this, which is more of what I think you would have expected the search engine to do in this case. But search engines aren't particularly clever, and certain other queries, if you had word 1, word 2, word 3, and you'd ordered them in the way that we had, you would interpret it a different way. So the problem with brackets is that they remove ambiguity and they clarify exactly what you mean, and you get the exact results that you're looking for. Is that if you forget to put one of the brackets somewhere, you get an error, and you get quite a noisy error. It just breaks completely, and the search engine will complain and say, "I don't know what to do. You started a bracket but didn't finish it, so I don't know how to end this pipe that I'm constructing." So my point is, could we make life simpler? Could we avoid the errors? Could we avoid the cryptic use of ands and ors and brackets and everything else? And I think if we just showed the flow, so showed these pipelines that I talked about, then it's quite possible to also edit them, to rearrange them. So you can just drag them and reorganize, and then you have what you were looking for. So my belief is that the visual representations of how these logic gates are sort of wired together is much better than trying to do it using text. Plus, we can automatically, when you change the graphical view, we can update the text with what you should have typed. So people can learn how to use ands and ors and brackets and so on by rearranging the graphical view. Or they could just ignore the text completely and just focus on rearranging things graphically and not care too much about learning the syntax that it updates the text with. So this is an example of a complex query, and you might look at this and go, I do not know what is going on here. I cannot figure it out. But it's true to say that if you show this as a flow, then a child of 5 could understand this. And this is why. Humans are very good at spatial navigation. And when you play any of these kind of side-scrolling games, it's quite obvious that you have to go through chamber A and then the next chamber to get to the chamber E. But in the middle chamber, we can go up or down. We have a choice. We can either go on the top and match B, or we can go on the bottom and match C, followed by D. So choices are up and down, and things that are mandatory just are arranged left to right. And that's a simple... that's the only rules you need to understand, and it's quite obvious to anybody who's ever played one of these games what the logic is here, and what the choices are, and what the available options are. So this is why I advocate using a graphical flow, because that image below is a representation of that horrible text-based query above, and a completely accurate one, and we can do that for whatever complexity we like. We can arrange it in this way of ands go across, ors go up and down. So the summary so far: text-based search is not great for organising multiple clauses using Boolean logic. All those ands and ors and brackets, it's quite easy to make mistakes. Up next, we're going to see why text-based search is not great for editing single clauses either. So even in a single word, there are things that you can do and control in text which are just really not the best way of doing things. There are things called reserved characters. So there's very cryptic looking characters that are quite hard to find on the keyboard. You can intersperse your text, talking about fish tanks or aquariums and so on, with these cryptic characters. You might ask, what are they for? What these characters, are they reserved for what? And the answer is controlling various clause settings. So there are a number of different things you can control or try and control using these characters. So things like boosts, number ranges, number of gaps between words that you're looking for, fuzziness, the ands and ors that we saw previously, choices of field like price or title or colour and so on. And all these things can be controlled using these reserved characters. And here's 5 reasons why those characters are really quite evil. Number 1 is they're hard to remember, so they're deliberately cryptic to avoid getting in the way of all the other words and characters that you use to type things like fish tanks and so on. So the choice of characters is quite bizarre, and it can be quite difficult to find them on the keyboard because they're very obscure characters. And it's very easy to forget exactly what these cryptic characters control. Is it fuzziness? Is it word gap? Is it boosting? And where do you find it on the keyboard? There's some bizarre combination of Alt and N and so on. The errors that are produced are quite noisy, so sometimes if you put this hat symbol here, then there's an expectation that you'll type a number to provide a boost, and if you don't, you'll get an error. Also, if you type an opening bracket or a quote or a square bracket, then you must complete the sequence and have a counterpart or a pair which closes that, otherwise you'll get an error. And these errors aren't friendly errors, they're quite cryptic and hard to debug, and saying, oh, you're missing something somewhere in your text. Perhaps worse than noisy errors are silent errors. So if you typed http:/foobar thinking you were searching for a URL, in many search engines that won't be doing what you think it's doing. It's actually trying to find foo.bar in a column or a field called http, and you wouldn't have realised that, and it won't tell you that that's an error. The impact on normal text as well is if you happen to have a character like Smith and Sons with an ampersand or something like that, then if you want to stop it, that ampersand doing one of these special control character things, you have to put a backslash in front of it to turn off that behaviour. So that means that people are just kind of naively typing words into the text, into the search engine, will be told, they've got an error, you need to put a backslash somewhere. One of the other reasons why reserved characters are quite evil is they're so cryptic, and that we've run out of them. So there are a number of things that I've personally built into the search engine as features in the back end that we just haven't been able to expose through the search box to users. Things like case sensitivity options, accelerated regular expression supports, phrases with choices of words at positions that we've basically just run out of magic characters like those strange at symbols, whatever, where we could say, yes, turn on the case sensitivity, for example. And really, we could make life an awful lot simpler. So if we have a graphical view, and I've got a term, a clause like aquarium, and we present it graphically, then a graphical clause can have edit panels, so we can drop down something, and we can have sliders, we can have checkboxes, we can have help text, all of the stuff that you would expect in a modern user interface. So quite why we're working with something dating back to the 60s, where we have to sort of type cryptic characters into a text box like we were typing onto some command line computer from a mainframe years ago. It's quite bizarre, really, that we're not using graphical user interfaces to control these kind of settings and things. There's more as well. There's more that can be done with a graphical user interface. So the text box can quickly get overwhelmed with long lists of things that you're looking for. So in this case, I've got a list of US presidents, which is just basically a big long Biden or Trump or Obama or Bush and so on. If we represent that graphically, then we can collapse that whole section of the query into something. We can give it a label. We can mute it. We can solo it. When we're querying, it's quite common to want to be able to just focus in on something or remove something while you focus on another area, and the ability to just mute and solo whole sections of your query is very useful, and we'll see that in the demonstration that I give later. We can also drag and drop, which opens up a whole world of functionality. You can drop things into it, you can drag it and use it and drop it into other places. The functionality that it opens up once you go graphical is so much more. So I want to take a quick detour. So everything I've been talking about up until this point has assumed that I am in control of shaping the query, using Boolean logic, using ands and ors and so on. There are alternative search approaches which don't rely on the user doing anything particularly sophisticated and using any of these ands and ors and so on. So these are what I would call search interpreters. They interpret what you type into the search box and do all the complex bits for you, which is a bit like ordering a ready meal. You know, somebody else has done all the hard work, and you just consume what they've packaged up. Myself, I prefer to cook my own and craft the materials and the ingredients myself and take control. But a lot of people are quite happy to just have like that sort of ready meal experience. So in these cases here, then the syntax the stuff you type into the search box can't use ands and ors and all those kinds of things. It's much, much more simplified. It's just, you type in a couple of words, for example. So if you typed in iPhone 10, for example, the sites will rewrite what you've provided using a couple of techniques. So approach number one, if you type in iPhone 10, what happens is there's a bunch of human-authored rules about how to interpret searches on this website, and we look up the relevant one. Hopefully there's a pre-configured rule, and this is an example of one here that says if somebody searches for iPhone 10, then the query you should actually run is iPhone and X or 10, but not anything that is a product which is a case or a cover for an iPhone 10. And the idea is that on this particular website, somebody searching for an iPhone shouldn't be presented with pages after pages of cases and covers before they actually see the iPhone. It gives better results. The people who run the website tweak this, and they spend a lot of time and effort customizing this. It's also conceivable that they could show this to you, perhaps in that graphical form that I've been describing, so that you could then tweak it further. I've not seen that done yet, but it's an interesting possibility. The disadvantage is it's quite labour intensive, so there are millions of unique queries that people run on websites, and the team who are trying to run the website can't write rules for every single one of these queries. So what they tend to do is focus on the most popular ones only, and everybody else's search experience is not quite as good because they don't have a rule, and it just matches whatever the search engine can find that matches that. Given how labour-intensive those handwritten rules are, there's a new and growing approach based on AI, or artificial intelligence. And in this, what we have is a very complex piece of software that essentially turns all documents and all queries into a series of numbers. And it projects each document or query into a vast multi-dimensional space, and these numbers are coordinates essentially into different areas of this AI's brain, and when it's in a certain area it can measure the distance between that concept and other concepts which have been sort of pinned in that sort of general area, which has been producing good results. So we'll match things like fish tanks and so on. But it can match other stuff which can be somewhat surprising. So it certainly reduces the labour. And the fuzzy nature of the matching, just this distance calculation from some area in a vastly multi-dimensional space, that's both a good thing and a bad thing. So it's good in the respect that I could search for fish tank and I could match a document that only contains the word aquarium. Because of the way it's clustered and organised these concepts, it can match things which are using words which are similar but not actually the exact ones that I typed into the search box. That's good. The disadvantage is it can also match things which you wouldn't expect, and it cannot begin to describe why that is the case. So these multi-dimensions that I talk about, these are some sort of abstract, machine-generated clusterings of things that it sees as related, and it's not something that can easily be explained to anybody. So in terms of control, you really are handing over control to this AI and saying, please try and match something, and it becomes very difficult to shape or refine your query if the conversation you're having is not based on keywords you both understand, but just on positions in this weird and wonderful space, this multi-dimensional space that I talked about. So I'm discounting both of these techniques where you're being aided either by a team of people writing rules or some AI. The concepts that I'm talking about is where the user who's doing the searches assumes complete control of shaping and refining the queries using Boolean logic. So with that in mind, I just wanted to acknowledge that these other techniques do exist, but for the purposes of this discussion, it's not something that I'm seeing as part of the picture. So back to banging in keywords and Boolean logic and so on. So until now, we've been thinking primarily about what happens when you type something into a search box, but that's only one half of where queries come from. So what tends to happen is you have something in your brain, you type it into the search box and you run a search. And the search engine goes away and then it produces some results. And some of these results might be just lists of documents and the raw content. And some of them might be summaries like pie charts and bar charts and maps and all those kinds of things. And this is where the other source of criteria comes from. So what tends to happen is that you discover something in these visualizations, these bar charts and so on, and think, oh, that's interesting, I might click on that. So typically what the search engine will do is it'll let you click one of the bars and you click, and then it drills down and it sort of narrows down your search results. So the mouse is another big source of criteria. It's where you discover things through these visualizations and you refine your query. But often I think the way that's managed is done very poorly. So you only get to click one bar and it does one thing. And it tends to be ever-reducing cycles. So what I mean by that is you type in some text. That creates one bit of the pipeline and produces a visualization. And you go, that's very nice. I'm going to click on that bar and then it adds an and. So it always seems to be an and to drill down further into that particular topic. And then you get a smaller set of results and then you might see another visualization. You say, there's a piece of that pie that I quite like, so I'm going to click on that. And then again, we narrow down. And what we're doing at each stage is we type something, we click something, and we're seeing less and less and less documents each time. But why is the assumption we always click to see less results? What happens if I want to see more results? So if I want to see more, then I need to use an OR. So that's a good way of remembering the fact that ORs are a way of seeing more results and not less. So let's look at what it means to have a search and discovery loop where you have the opportunity to click on things and make them an OR. So let's go back to our fish tank example. So if I search for fish tank, there's my fish tank query, and we get a visualization that says there are some related tags here. So aquarium and vivarium. Now, they might be words that I didn't know about before, but I understand now that they're connected. So I might want to use my mouse and I might want to select two things, not just one, and drag them as an OR. So now we've expanded our query. We're looking for fish tank or aquarium or vivarium, and we've got more results, not fewer. So previously we were only looking at perhaps 50 documents or so that had fish tank, but we might have upped that to 200 documents because of aquarium or vivarium were given as alternatives, ors, not ands. there's yet another trick that visualizations could do. So as well as allowing you to select multiple things and drag them and use them as an OR, we can potentially use them in other ways too. In this example visualization here, these are things that the search engine has suggested for us. So it's given them to us and said, we think these are related terms, and that's kind of interesting. And typically these terms come from a choice of field or column. So they might be from tags, or perhaps they're a list of brands, or a list of makes and models and that kind of thing. But quite often, what we want to be able to do is take our queries and make those the subject of the visualizations. We want to have a look at these things and drop them into the visualization and say, I want a bar chart, or I want a map, or I want a timeline that includes these subjects defined by us, not suggested from the database or the search engine, things that we've handpicked and built and defined. So let's have a look at an example of that. Well, we're looking at one on the left here. We've constructed this query that says fish tank, aquarium and vivarium. So we can take this query that we've built and we can collapse it and we can label it. So we can call this fish tanks. Now we can do a similar thing with another topic here. So here we have rabbit, and then we've got hutch or cage. So we might have a number of products in our shop which are rabbit hutches or cages. And again, we can give that a label and collapse it. So now we have two topics, rabbit cages and fish tanks, both of which are relatively complex queries. And then we can drop those into a visualization to compare them. So we might be interested in the sales of these two products or product types. So we don't have a single field, or a single column in the database that says product type rabbit cages, product type fish tanks. We've just constructed a query that brings these categories together based on the text of the product descriptions. And then what we can do is just drag those into our visualization. And we can compare and contrast those two product types. So we've just at query time decided that this thing that we're using to sort of filter our documents, now that we've defined two of these topics, then we can drop them as the subjects into a visualization. So visualizations are there to show you things in context, so either based on price or time or geography or whatever. And we should really be able to be free to drop whatever subjects we like into there and say, I want to render this concept on this particular style of diagram. So all visualizations that are part of this ideal product that I want to create should be able to both produce query clauses when you click on certain areas of them, but they also should be able to accept them, and they should be able to drop your constructed queries and labeled queries and just drop them in there as the subjects that are going to be shown. So there's lots of reasons why I think we should do this sort of graphical flow-based representation of queries. I'm not going to run through them all here, but there's a lot of very good reasons why that's an improvement over text. And hopefully to illustrate all that, we're going to run through a demonstration, and we'll use some real-world data. I mean, it should be obvious when you start to see how all these things come together, how this is a much more simple and powerful way to work. So if you made it through my presentation on the search box, you'll be aware of the various different limitations that we often see when we have a traditional sort of application with a search box and search results and visualizations and so on. So in this demo, what we're going to look at is an alternative which expands upon the search box and fills in a lot of those limitations and provides new capabilities. And what we're looking at is a demo web application built out of the AndOr search components, which are designed to present a graphical representation of queries and talk to a number of different databases or search engines in the background. Today we're looking at the Elasticsearch search engine as our back end, and we're looking at a bunch of nearly 250,000 news headlines gathered from various different news providers from around the world over a period of a couple of years, really. So 2 or 3 years, so that's obviously going to span all sorts of news events. I don't think much has happened over the last few years, but there's a few things that we can probably have a look at. What we'll do is we'll start by looking at an example of a single search term and where we run into difficulties with that. So I'm going to search for the World Health Organization, WHO, and the problem that we have here is that we're matching content that's just using the English word who, as in who is this, who is that. Now this is a problem that we actually addressed in Elasticsearch in the back end. It was one of the last things I worked on. It was a fairly simple change to allow at query time users to say whether or not they wanted case sensitivity on or off. And the most difficult challenge in all of that was actually exposing that and putting it in the hands of end users, because we hit the limitations of the search box. So how in the search box, what syntax am I going to use to say that I don't want the search engine to lowercase as it normally does this particular word? And, we went through various different thoughts and ideas about why they could have a /I or something. We can invent some new sort of syntax. But the problem with inventing new syntax is you need new control characters like /I or something like that. And then end users have to know that that's what they're supposed to do. But it also has a backward compatibility issue. So there may be any number of queries out there in the wild that are running on a daily basis, and they happen to use /I or whatever it is, and that's used to match the text of a document. And if we suddenly declare that, oh no, it's now being used to control this new feature that we've added, then we break their system. So that's an example of where the search box is holding us back. We can't expose this new functionality. So that's why it's useful to actually have this alternative graphical representation of our query. Now this representation is completely responsive to whatever I type here, so if I type more characters and more words here, then we update the graphical representation. But what it also provides is the ability for us to go in and have a look at the settings of these query objects that the query parser creates. So normally we want our search terms to be lowercased and allow these sort of variations to match, to be a little bit sloppy, but in this case we want to be completely exact. So that's just a setting. We've got help text, we've got a checkbox, or a radio button that can turn that feature on. And if we look at our search results now, we're getting what we would hope for. We're actually matching the World Health Organization, and we don't have all these kind of who is this, who is that type documents. So that's a good example of where the graphical interface can overcome the limitations of the search box. And you'll notice that the text has actually become this sort of opaque block here. It doesn't prevent us from continuing to type things like and Fauci, so we can continue to use the search box as a search box, but it's smart enough to know that there's certain clauses that are using settings and properties which can't be expressed in the search syntax. So that's why we end up with this sort of block here, and we have to do our changes and our editing down here now. So let's move on and look at an example of where the graphical interface helps us compose multiple words, not just a single word. So obviously the big topic over the last few years has been COVID, and another term that's been used for COVID is coronavirus, and we might be interested in looking at all the various different strains that have been out there. So our query is using and as the default operator at the moment, so we're looking for COVID and coronavirus and strain. And this has limited our search results to a very small number, so we've only got 4 matches in total. And we can display graphically how that happened. So if we hover over here, we can see that the first term, COVID, had 13,000 matches nearly, and then the documents that had COVID and coronavirus in them only numbered 492, And finally, we added strain as an extra filter, and we ended up with only 4 matches. So clearly we can do better than that. In my presentation, I talked about some of the difficulties with typing ors and ands and having to use brackets to avoid ambiguity. Doing an or in the graphical interface is as simple as just picking up a term and dragging it into underneath the things that you want to or it with. So you'll notice that it's actually updated the text box, so it said COVID or coronavirus, and it's put the right brackets in and strain. And we've now got 126 matches instead of 4. If we hover over here, the or block, we can see the breakdown of what happened there. So we almost doubled the number of results that we were getting. So COVID was 12,000, 13,000 matches, and we added another 9,000 matches for documents that use coronavirus instead of the word COVID. If we fold this up out of the way, then we sort of simplify our search box a little bit. So we're looking for COVID, coronavirus, and strain, and now we might want to look at synonyms for strain. Now I could come up with those and type them in here and type or mutation or whatever. But one of the tools that we have in Elasticsearch is the ability to suggest from the matching results significant keywords or phrases. So if I go through this list here, we can see that mutant is one possible, mutated, variant is another good term that tends to get used, or hybrid. And I might choose to make these selections here and drag them into my query. Notice here that rather than being a bar chart that lets you click exactly one thing and make it an and to whatever's in your search box, what we're doing here is we're selecting multiple things and we're making it an or. So we're not asking for fewer documents, we're asking for more documents. So if we drop this in, our 126 documents here will be expanded to 615, so it's quite an increase in the number of results that we have. And again, our search box might be getting a little bit muddled here with all these long lists of things, so we can just fold that up again. We can actually give these things labels as well and stuff like that, so we remember what the various different things are. So the purpose of me defining COVID strains was for me to actually go back and remind myself of when all the various different strains came in over time. So if we look at the related terms here, we can start to see some of these keywords come through. So the Delta strain, I recognise that as being one of the strains. Omicron is another big one. If we go through down here, we can see Lambda down there as well. That was another strain. So again, cherry picking multiple items. This time we're going to drag and drop it in as an and. And then I'm going to twist this round. So this list of these 3 variants that I'm aware of, I'm going to hit exclude and take them away. So we're now looking at fewer documents, but it allows me in the significant terms to start to look for other variants outside of these major ones that I might not have known the names of. So one example down here, mu COVID, I'm not quite sure what that is, so we can just pick that up and add that as an and here. And we can have a quick look and say, Fauci says the new mu COVID strain isn't a threat, blah, 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 blah. So mu COVID did appear to be a variant at one point in time, so let's drop that into our query builder here. In the exclude list, and let's go through and try and pick up some other ones as well. So I'm just going to go through here and pick up UK variant. IHU, if I drill down again, that tells me that was a variant, so I won't take that particular detour. Let's add those into our exclusion list and just make sure that we've got all the ones that we're interested in. So let's just see if we got there's one more variant that I want to pick up. Yeah, here we go, the Indian variant. So let's just grab that and drop that in there. Right, so now we have our list of variants. So I'm going to make that an include now. We've got our list of all the various variants that we were aware of over time. And we want to see when they came in. So if we go back to our dates visualization here, one of the points I was making in the presentation is that visualizations normally are telling you things. They're suggesting things to you from the database or the search engine, and you don't have much control over what might be coming up here. So it's a bit of like a one-armed bandit. You sort of pull the lever and hope that the right things come up, or interesting things come up at least. And we can take more control over what it is that we're actually visualizing. So we can use any query term and pick it up and drop it into our date visualization here, and it can receive this query and display it as a sort of a swim lane in this visualization. It dropped it in here as a sort of a composite pack of 7 different clauses, or 6 different clauses. So I can unpack them here, then have a look at them across time. Now some of these are quite tiny. They're only getting news articles that say there's 1 or 2 events occurring on a particular day. So to help me see that, I can sort of zoom in and have a look at the different variants. So one of the things that's kind of interesting is the way we used to name variants. So we had things like the UK variant and the India variant. And at round about this point here, we decided that we would stop stigmatizing countries as being the source of a particular variant, and we started coming up with these names like Lambda and Delta and so on. And that switchover, we can see here, the India variant and the Delta variant happened round about this period here. So there's a sort of a crossover period where people were using Indian variant and Delta variant interchangeably. And because we now know that these are essentially the same thing, what I might choose to do is pick that up and drag and drop it on top of this one to merge the two together. So now we have sort of the India variant / Delta variant as a single line. We might choose to take the fader back down again and see just how many of these things there were. So that was peaking around about here in the middle of 2021. Now that act of dropping one thing on top of another, that was essentially just creating another OR clause. So there's an example. All these things end up being query objects, and you can go in, you can change the settings, and you can pick them up and you can merge them and drag and drop them to your heart's content. So you can recompose the queries, you can fold them, you can give them labels, and you can drop them into visualizations in ways which you can't possibly begin to do using the search box. So hopefully that gives a flavour of the sort of things that you can do and how it improves radically what you can do with the search box and various different visualizations.